Hello guys, welcome to my YouTube channel. So today I am going to show you how we can perform the data cleaning part for the categorical data. So let me use the heading here, categorical data cleanup. So in categories, right, we have number of categories like the name and whatever the we have in any data set based on the data set. Our categories varies based on the data set, but the operation we perform on the categorical data with sometimes similar. So now this is my data set. This is the rolling stone data set. So you can see how I just print out the first 5 rows which contain the unnamed zero. This is the serial number column, this is the name column, this is the album, this is release date, track ID and things like that. So I'm just clean up this data and I will show you how you can perform the categorical data cleanup part. So let's go ahead for the first part. First part is I am just dropping the unwanted column. So in my data set I am just dropping few columns. I am using the drop method for this. Then I will use the labels equal to. Then inside that I am using the ID, comma. Then I am using the unnamed zero. This is the serial number column which is not required for us for predicting something. And also one more column is the URI. So I'm just dropping it. It will give me error because I didn't mention here the axis part. So axis equal to 1 and in place equal to true. So which means that drop my column and perform this data on the df variable. So now you can see that I have the name column, album column, release date column, track number column and all other columns which are the numerical data type. So now I have two columns which has the categorical data type, name and album. So I have like the, let me put the unique of the name. So if I use the name dot unique method which can give me the name of the all unique songs present in my data set. So you can observe that I have lots of unique songs. Let me do, you can see, observe that I have lots of unique songs, but these are all unique songs, right? But one thing is that if you observe this data very closely, so you can observe that there are number of repetition of song. Like you can see here, like let me give you some example. Okay, in the album dataset also we have some of the example what I am going to explain you. So if I use the unique here as well inside that album column, so we can observe that they have some repetition of song. Only the case of the song is not matching with the other one. So here also you can see that this both two songs are the similar, but their versions are different. So that's why we can consider it as a different song. Now you can see that in my songs data, right, in my album data I'm just printing the unique values. Now you can see that this two attribute, you can see that December, children's and everybody, these two songs are same, means these two albums are the same name. Only my data set is not detecting it's the same, it is detecting it's a unique. Why it's detecting it's a unique? Because here I am using the single inverted comma, here and here I'm using the single inverted comma, and here I'm using the something like different notation for differentiate my yes. For the December's, for defining my yes I am using the different notation here, and for here I am using the single inverted comma. So that the way it is predicting my this song and this song has the different, these two are the different albums. But actually if you seeing that using the human eye, you can observe that these are the same, right? Because the name are same and everything is the same, so that's why it's the same. So here you can see that also one thing is that here is that you can see that out of our head US sequence, and here you can see that out of our head UK, sorry, out of our head UK sequence, and here you can see that out of our head UK. The only sequence is not added, but everything is the same, right? So this is the our similar songs or similar thing, but only because of the they have the categorical output, my data set or my machine learning model predict it's a different one. So also I have the example of the cases for the case version as well. Like let me see, like where can I found out that, but you can observe that these are my different same column, but because of their cases are different and the single inverted commas are different and some extra dash or extra spaces which are added, so that's it's predicting my to the different things. So we need to solve this problem, right? Because in machine learning model we can't say okay, this is my output, so you should predict something like that. Here is the example of my got here is the example of my character, like the uppercase and lowercase differentiate character output. So now you can see that in this column got live if you want it, and here is also got live if you want it. Only the difference is that the G of got here is a small and here is the capital one. So because of only this one, it's predicting that these are the two different songs. But actually these are not two different songs. These are the two. This is the same song. Only the characteristic is different. So this is the like errors or impurities in our characteristic data. So we need to fix this impurity because we can't go with this impurity because our model will be then produce a lots of error output and produce the problem of underfitting or overfitting if we go with this impurity. So we need to fix this impurity before going to train our model. So for doing that, we just need to use some of the data cleaning process for cleaning those things. Let me explain one by one step how we can do that. There is no library which present as of now for cleaning the, we just give them the categorical data and predict the output for us. This is not as of now developed yet, because every categorical data is different, everything is different. Based on data you just need to use some methods and predict the output. So there is nothing like which we can like plug and play system here. So we just have to think around that, and based on that remove the errors and make sure remove the impurities of our data set and make sure our data set will be clean. So for doing that, let me use something. Let me go first for the name of the song column. So you can observe that there are some characters in my song name have capital one and few are the small one, right? Here is the combination of capital one and small one character. So because of that, maybe because of that, it's predicting like the same song with the two different entities. I am converting everything which is in the lowercase character. So how we can do that? We can use here the name equal to df dot name. I am using the apply method here. Apply. I am applying the lambda function x comma x dot lower. I am just using those method, and if I hit enter, if I print that df of name, now you can see that my all the things are converted into the small letter. In that way, I am get rid of the capital one and the letter or case sensitive impurity. Because of this operation, I am getting rid of this impurity. So if I use here like okay, let me use, before that let me show you like how we can do that as well. Let me apply this same thing to the album. Here is the album is also that I am using, but before predicting the album or before converting the album to my different one, I am just using the album with n unique, means number of unique. Just give me the count of what is the unique value which are present in my data set. Now it will give me some output. Then I will run this one, and again after that I will run this one like df.album, the same operation. Okay, I didn't run this cell yet. I just use the I just run the above cell before that. So now you can see that before the clean up the data for the lower impurity, case sensitive impurity, there are 90 record which are unique one. But if I hit enter for this, means I just converted my or remove the impurity, and after then I am just using that. You can observe that there is the 88 record, unique record, which means my two records which are same characters, but my model is predicting the output. So we are just remove those impurity for the inside from our data. So now my characters impurity which is gone. Now let me do here again like df of name dot unique. Now you can observe that there is also the few impurities which are present. I will explain you one by one approach like how we can solve that. You can see that there might be the case that if someone added this extra space between my heart of and the heart of here, and because of that maybe some songs are predict or my algorithm predicting same song but uh, treat as a individual or a different one. So for removing that space impurity, what we can do, we can remove those space for every name. So how we can do that? Let me do these things. So we can use same lambda function, but only here I am using x dot replace equal to older string what is the space and new string no space is required for us. So this is my impurity for the space impurity that I am going to remove, because I am not sure, right? Because I am not sure about the like what is the present, is that duplicate or double space is present in my names or not, because this data is not created by me, this is created by someone. So maybe there is mistakenly happen they enter the two spaces, which is not predicting by human eye, but they may be the condition there the impurity is present, we are not sure that. So that's why we are just removing the space. So make sure our every song will treat individually and there is the no duplicate or there is the no impurity found in our database. Now if I hit enter, okay, it is giving me some error. Let me see what the error look like. Okay, I'm using the name apply, I'm using the lambda x dot replace. Okay, I'm just using this for only this one. Replace this one. Now you can observe that my execution code execution successfully. Let me use here as well, let me use here the album, and I'm just assigning this thing. If I use the df dot head of 10, now you can see that my space in my song name or in my album name the space is removed. Now it can, there is the no space impurity which are present in my data set. Now let's check for the other impurities. So what will be the other impurities? Like let's print our unique values for the album data set. Now you can see that right, space impurity is gone, right? There is no space which are found, but there have some other impurities which is like the hyphen one and the slash one. This is slash, maybe there in the maybe there is a condition, right? Someone didn't use the slash for one name and for another album name someone uses the slash. There is maybe the possibility for this. So get rid of this impurity, we use the same thing but with the slash one. So instead of space I am using the slash. I am not like removing those things, I am just using the slash. Now you can see, now you can observe that my slash impurity is gone, there is no slash present in my dataset. Also before started we observed that there have some cases where the people are using the single inverted comma only single for the declaring the yes, and sometimes there is the other symbol, this one is the other symbol which are present, and there are some other symbol which is like yes is under single inverted comma is present. So these are the two impurities. So we need to get rid of this special character as well for treating this categorical data. So for doing that, let me use the same thing. Instead of doing that, I am just using the single inverted comma. Here is also I am using the single inverted comma. Also I am using that special character which is present on my data set like this one. This is little bit different character, maybe you are not observing it, but there is some tilt present in this single inverted comma. So let me run this one and let me now execute this one. So if I do here like number of unique, when we are doing that, at that time there are like the 88 unique albums present in my data set. Right now there is like 86. Now you can observe that my impurity is, my data is reducing impurity, right? It is clean up, it's reform it and it will become clean up itself. So now you can observe that, let's see, is there any special character or anything present in my data set or not. So there is nothing is present as of now. Based on that, you can also remove this square bracket impurity, because maybe there is some cases that the square bracket is not present and square bracket is sorry, bracket is not present and bracket is present, there is the case. So that's why you can just remove those things. Also you can remove the special character like the dash one. For the numbers, right, you can keep the numbers, these things, because there are the version of songs. So the one song which has same name but the version is different one, like the 2024 is the different version and 2028 is the different version. So we can make we cannot remove those the number level impurity or the number level things. We just only remove the special character level impurity. Now let me go ahead and remove that the brasses impurity as well, like this one. In my data set I have like the circle brasses, so I am just using the circle brasses here. If your data set has the other brasses, then you can go ahead with this. And also I am using the impurity for explanatory mark. So here I am just using the exclamatory mark and here is also exclamatory. So now you can see that my data is more clean, right? So there is also the dash impurity which are present in my data set. Let me use the dash as well. So here I just need to use the dash. If that underscore present in your data set, then you can also use the underscore. Now you can observe that the dash impurity also removed. Now my data is more clean, right? My data is more accessible and it has like, let me use the like album here and use unique. Now it will give me the number of unique value present in my data set. Now there is count is like 86, which means like my all impurity is gone and now my data is not clean up that much. So that's why it's a point where the threshold found. So we can stop here and we can observe that. Let me print the df here. Now you can observe that my name column has the constructive data, my algorithm column also has the constructive data, and before means when we started before our data look like this one. So this data set is not a cleaned up, it has some impurities, and after our cleanup our data set will look like this. So it's more clear and more usable and we can apply the machine learning model on this data set. We can't so we did cleanup and all. So that's the pretty much for the data characteristic cleanup, how to clean up characteristics data set. So that's pretty much from my side. Thank you so much. If you like those video, please hit subscribe button, also like those video, hit the like button, so you will get the more hands-on experience regarding that. Because what I'm doing, I'm just learning things, I'm trying to implement those things on my real world use case, and if I found some like the genuine use cases, so then I am just using or I am just recording the video for those. So in that way this video help for you as well to implement those things. So yeah, that's pretty much from my side. So this is not the theoretical part, this is the practical explanation. And also you can, when you join as a machine learning engineer, if you are working as in a machine learning engineer, you observe that you are get those things, you need to deal with those things on regular basis. So you should be more clear, more like more hands-on experience on that. So that's pretty much from my side. Thank you so much.